All right, let's do a quick walkthrough of the Module 7 assignment. We're going to take a look at just two questions here. I think that'll hopefully move it along and give you some insight in how to do these. And once you figure them out, it does take some time. So the one unfortunate aspect is we don't have a lot of time to go through this, or patience. You really have to go through this quick. With more time, we would spend a little bit more, of our class kind of dedicated to this. But let's see if we can kind of make some sense of a couple questions here, and hopefully that'll answer, some of the, or alleviate some of the confusion. So our first question here, it just wants to look at individuals who file their income tax at the last minute, okay? And so we can see like some of these people, they receive an average refund of $1,100. That's tax returns 2 weeks early. So these are the early filers. They want to get their money quickly. And the hypothesis they want to ask here are the people that get smaller refunds, do they wait? Because they don't care as much. They're not as concerned about getting their refund back. All right, so last minute filers, the people who file 5 days before the deadline, they will take a sample of 400 people. In this particular case, it yielded a sample mean of $970. That was their average refund in the sample mean. And notice here too, we say the population standard deviation for returns is assumed to be $2,000. Okay, so that's a big clue. That means we're going to use the sigma known template since the population standard deviation is given to us. And then we're going to let alpha be 0.05, so 5% of our alpha. Okay, and again, going back, we want to understand the concept of our test right here so we can set up our null and alternative hypothesis correctly. Okay, so $1,100 is going to be our hypothesized value. That's what we're testing against. And then we have our sample mean, we have our population standard deviation, we have our sample size, and we have our alpha that we can put into our template. First part though, let's go ahead and specify our test. So what you want to think about as you do this is what are we trying to show here? And in this particular case, if this makes sense, I'm trying to show, and this is the question that's kind of getting at this, if the people who waited till the last minute, so the last minute filers received a lower tax refund than people who filed their taxes early, okay? So to me, when I read this, it kind of sounds to me like a lower tail test. It's less than, it's lower than, something like that. That's the keywords you're looking for here in terms of setting up this test and what you're looking for. All right, the null hypothesis we're always going to keep the same, so there's just going to be equal to some hypothesized value. In this case, we're comparing it against that $1,100. Sometimes that can be tricky for students to figure out what is this hypothesized value that we're working with. It's not the sample mean, right? It's this value that we're trying to compare against. We're checking to see if, in reality, this is kind of what we're going for, if this is essentially, are they actually getting a less of a refund? Okay. Now our alternative hypothesis, this is where we're showing the result that we're looking for, right? So in this case, I want to test to see, right? What am I trying to determine? We said it's a lower tail test because I want to test to see if that true population mean is less than $1,100. That's what this M right here represents. That M is the population refund for the late filers. So we're testing right here if that true population mean is less than that. And the whole reason we're doing the test, because we don't know what that is, right? So we took the sample to estimate that, and then we're going to use statistics to give us the results here. All right, first part then, get the test statistic p-value, and then what's the result of the test. Okay, I'm going to grab my stuff. Let's do this. We know all our values are getting up here. I'm going to open up my template. And remember we said population standard deviation is given to us, so we're going to use, make sure you've got the right template in here. So sigma known template, if you use the wrong template, the values will be off. Okay. All right, so $1,100 was our hypothesized value. $970 was the sample mean. They said assume that the population standard deviation was, I want to say 2,000, but I want to go back and check that just to make sure we're right. And the alpha is 0.05. Okay, so 2,000. 400 in the sample, so a large sample, and 0.05 is our alpha that we have here. Okay, so everything else kind of fills in itself. We find that standard deviation for the sample mean, we find the test statistic, and remember we're doing a lower tail test in this case, so remember as I do that I just want to report the lower tail value, which is 0.097, the lower tail p-value that we have here. Okay, I'm going to sneak back up and we're going to plug these guys in right here so we can say the test stat was equal to minus 1.3 and the p-value for a lower tail test was equal to 0.097. Okay, minus 1.3, and that's because negative, because the sample means less than the hypothesized value. Okay, now we want the conclusion of the test. We can see that the p-value, however you want to describe this, you can just say, in this case, the p-value of 0.097. Just want to do a quick check here. Don't make a mistake on this one. It's a test. You're just checking it, right? You've got those values. Just test them. Is greater than alpha, which was 0.05. And so that means, right, because the p-value is too big, we don't have enough information to suggest that the refund is less than $1,100. So the first thing we usually use to describe this then is if the p-value is greater than alpha, we do not reject the null hypothesis. Do not reject the null hypothesis in favor of the alternative. Okay, so that's the statistical way to describe this. Do not reject the null, okay? So it means I have no indication to say that I think the alternative is true. We're going to try to avoid using language that says like accept the null, anything like that. Just say do not reject the null, not accept the null, just do not reject the null. And I know that language can be quite confusing. Once we write this here, this is correct. We do not reject the null, but our audience might not understand this because you can tell the language is so confusing. Let's try to write it a different way where it's going to be relatable to people, where they'll actually understand the result, right? So now we want to say something that, we cannot suggest that late filers have a return less than $1,100. We don't have enough information to suggest. So that would be a way. There is not enough information to suggest that late filers receive a refund, an average refund below $1,100. There's a lot of technical language in here, right? So the average refund for these filers is less than $1,100. Because we do not reject the null, that's our result that we have here. All right, this can be quite confusing trying to get all of these pieces correct. There's a lot of steps to follow here, right, to get to this level. That's why it's kind of nice to have the template set up that it just gets it for you. Okay. All right, so that was number 5. This looks good. Again, the result, we do not have enough information to suggest that late filers receive an average refund below $1,100. And so people should be able to understand that. All right, number 6, a random sample of 25 cell phone bills suggests that the sample average price is $89, so it's going to cost people $89 per month. Sample standard deviation is 33. Okay, that's another clue. We're given the sample standard deviation, so we know this is going to be the sigma unknown template that we have. All right, I'll let you go back to last week and I'll let you use your sigma unknown confidence interval template to do that confidence interval. That's just practice, so you can see that. And then answer that question. I'm going to go ahead and skip to part C. A study wants to determine if cell phone bills are higher than $100. So we'll specify that null and alternative hypothesis and we'll do the test here in a second. All right. Now, we can set up this test if this kind of makes sense. The test wants to determine if your cell phone bill is greater than $100. We'll specify the null and alternative for this one. Okay, so in this particular case, $100 is going to serve as our hypothesized value, and our null hypothesis that we have here is just going to be that the true population mean cell phone bill is equal to $100. And then if I use the language in here, higher than, So I think what this is actually referring to in this case, I want to see if it's more expensive then. We might be doing a test to see how expensive cell phone bills are. Higher than 100 just means greater than 100. All right, so if this is an upper tail test, which is what it kind of seems like we're going to do right here, we're doing an upper tail test to see if that true population mean cell phone bill is greater than $100. I don't have access to all that, so what I'll do instead is do the hypothesis test to see here. We're going to use alpha 0.01 and do our test. Now here's a quick thing to just kind of think about, and especially at our level right now, just being introduced to this now, notice that I want to test to see if the average phone bill is greater than $100. That's probably very, 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 very unlikely, meaning our p-value is going to be really, really big. And that's because, look, if our sample average is lower than 100, what's the chance, right, that it's actually going to be greater than 100? Very, very, very small. So we'll see that. So I'm going to go ahead and say, be ready. We're probably going to get a p-value that's really, really, really big for an upper tail test. Okay. All right. We're taking a look. N is 25. Sample mean, X bar 89, sample standard deviation 33. Let's plug our stuff into our template. Coming back here. Okay. I forgot to say too, notice how it's red, so for our last problem, so that was a do not reject that we have there. Okay. I'm going to use my hypothesis test sigma unknown template in this case, and that's because we've got the sample standard deviation that we're using. All right, our hypothesized value is $100. Sample mean was 89. Sample standard deviation 33. N was 25. We let alpha be 0.01 that we have here. Okay. All right. Now, in this particular case, it's an upper tail test. Check to see, hopefully your sheet matches. You've got a good sheet here. You can just plug these values in. We've got the test statistic, and we got the p-value for an upper tail test. Kind of mentioned earlier that it's probably an upper tail test, and that looks correct right here at 94.6% for our upper tail test that we've got. Now, if you want, this was my mistake. I just forgot this, so I'll be really careful. Of course, if there's any mistakes, I will not hold you accountable for me forgetting this right here. But you'll notice there is an error in the two-tail calculation, so you might have noticed that, even though we don't need it here. If you want to fix this, the problem that happens, and I forgot with this particular function, is that it doesn't like to read negative numbers. Okay, so see how we've got this negative 1.67 in here? It doesn't like that. In any case, if you're going to do a two-tail test and the test statistic's negative for our sigma unknown template, it's going to spit out this number error. If you want to fix this, you can. I'll try to make sure, again, if there is a question that uses it, I wouldn't fault you for that. I wouldn't take points off for that. And I will try to avoid using those questions so we don't run into it. If you'd like to fix it, in this case, one thing you can do is just take the absolute value of this and put parentheses around our test statistic that we have here. And what that does is it just makes any negative number positive, and a positive number stays positive. So that's one solution you can do here to get that value. All right, so that's just a little hint. At any rate, we're looking for the upper tail here, 0.946, the upper tail test, and minus 1.67 is our test statistic that we have. Okay, so here we're going to put our test statistic, test stat. It's a very big test stat, and then the p-value was 0.946. It's actually really, really quite big. What's the result of our test? Again, see how it's red? See how it's bigger than alpha? The p-value is much, 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 much bigger. It's very, very, very big. So because of that, we could say like the same thing. The p-value is greater than alpha. And what that means is do not reject the null hypothesis in favor of the alternative. Okay, we can say this in a slightly different way. There's not enough information to suggest that the average monthly phone bill is greater than $100. Okay. All right, and that's our result that we got from our test. So statistically speaking, it's going to tell us all that stuff. All right, now for these other ones, hopefully this makes sense. You're going to go through and you got data, but you're going to plug that data. You're just going to go ahead and get those averages and the ends. In this case, see how the population standard deviation is $800, so you'll use sigma known case. Think about what you're trying to find here, and you're going to use those values that you've got. Okay, the same thing for this last one. You're going to use the data, but you're still going to use your templates that you've got. Okay, so I hope this helps save you a little bit of time. If you have questions on this stuff, of course, please let me know, and we're almost done. So good luck. I hope it goes well.